Okay, so I'm hoping that this works the way I'm expecting it to. This is my first video, so congratulations. It's a big deal. Okay, so here was your homework last night. You were supposed to make sure that you had these in the correct spot and then also factor and graph them. So here's the very first one. You'll notice when you factor this, you do get x minus 5 times x plus 4 over x minus 2 times x plus 1. The interesting thing about that is that in your denominator, I don't know if you really can kind of see this, but in your denominator, the numbers that you would plug in that would give you a 0. So, x equals 2 and x equals negative 1. Those happen to be your vertical asymptotes right here. So in order to find a vertical asymptote, if you're not given the graph, if you're just given the equation, you look to see what makes your denominator equal to 0. Those would be your vertical asymptotes. Okay, so same kind of thing in this one over here. We have two vertical asymptotes. Once we factor, we can see that one of them is going to be at x equals negative 2. And then the other one is going to be at x equals positive 2. Okay, so again, even without the graph, we would know that that's where the vertical asymptotes are. Wholes are just a little bit different. So the thing that you'll notice with the equations here is that when you have factored, if you have a whole, you'll end up in this situation where, let's see if this pen will work. Nope. You have this x minus 1. None of my pens are working. See if this one will do anything. There we go. Okay, so you have x minus 1 in the numerator, which cancels with that x minus 1 in the denominator. Okay, so this guy up here, this equation actually simplifies to 3x plus 1 over 4, which is a linear equation. So you'll see when it graphs, it's a line. Okay, which can't make sense because when you simplify it, it's linear. The only problem that we have is that the original problem wasn't linear. The original problem was quadratic, divided by linear, and then we canceled this part to make it linear. So because we canceled this part, in the original problem, if we had plugged in a positive 1, it would have given us a 0 in the denominator, which would make it an undefined number. Okay, so what we're going to do to kind of compensate for that is we have that line for our simplified equation, but we just draw this hole because in the original equation, if we plugged in a 1, if we plugged in x equals 1, we would get an undefined number, or the number wouldn't be defined. So this whole function right here exists except for at that point. Okay, so same kind of thing on the other one. The x plus 2 will cancel with the x plus 2. Okay, and because those two cancel, you're left with this equation y equals 2, which is that horizontal line right there. But that wasn't the original equation. In the original equation, if we had plugged in a negative 2, we would have gotten an undefined number. So again, we compensate for that by just putting a little hole right there where negative 2 is. So on the graph, we put it where it should be according to the pattern, I guess in this case, but you just don't actually have it there because you can't have it as part of your function. Okay, and so then the last one's down here, we're looking at both. Okay, so this is not the best graph drawing, but you'll notice I do have this x minus 1 that cancels, okay, which gives me this hole right here, that hole right there at x equals positive 1. Okay, but once I have that done, I'm left over with this in my denominator. Okay, so because that's in my denominator, if I set that equal to 0 and solve, like if I said 4x plus 1 equals 0, and then I solved and got x is equal to negative 1/4, that's where that vertical asymptote is right there. Okay, so the holes come from the things that cancel. The vertical asymptotes come from the things that are left over in the denominator. Okay, so on the other one, I've got one other practice problem. We have that x plus 3 that cancels, so you have that hole right there at x equals negative 3. And then we're left with two factors. One of them is their 0. Okay, so I know this one's kind of hard to see, but you do have a vertical asymptote at x equals 0. Okay, and then you also have a vertical asymptote where 3x plus 2 is equal to 0. Okay, so which is right there at x equals negative 2/3. Okay, so again, holes are the ones that cancel. Vertical asymptotes are the ones that make your denominators equal to 0. So again, in this one, we have a vertical asymptote here at x equals 0, and then we have a vertical asymptote here at x equals negative 2/3. Okay, so I didn't have you guys yesterday cut out your pink pages, so go ahead and do that. And then flip your paper over to the back. You're going to kind of label it as vertical, or sorry, that's not true, horizontal asymptotes and slant asymptotes. So you'll have the green on the front, pink on the back. So you're going to cut out your pink pages, your pink slips, and then graph each equation. Okay, so I know I have a lot of work on here. I couldn't bring an extra one home with me to work, but once you cut out your pink ones and you're going to graph your equations, you can look and you can see on the graph if it has a horizontal asymptote versus a vertical asymptote. So, let me see if I can get this doing anything interesting. I think I'm doing it. If I go to Desmos, for me, because I don't have my graphing calculator, you can use your calculator. Or if you want to use Desmos, that's fine. Type in, excuse me, y equals, I'm going to do x squared plus 2x minus 3 as my first one, divided by 2x squared minus 4x. Okay, so in this one you can kind of see it does have two vertical asymptotes. You have one right there at what looks like x equals 0, and then you have another one right here at what looks like x equals 2, which really makes sense because if you factor out a 2x, you're left with x minus 2. And if you set this equal to 0, you'll get 0 and 2. So you have those two vertical asymptotes, but what we're really looking at is comparing horizontal asymptotes and slant asymptotes. Okay, so horizontal asymptotes are one like this, okay, where you can see this very defined line, where you have a horizontal line right there that it kind of gets, the function gets closer and closer and closer to, but never actually touches. Okay, so this line would be, I think it looks like y equals 1. Oops, that's not true. Y equals 1/2. There we go. Okay, so that would be our asymptote, our horizontal asymptote in that case. Slant asymptotes are a little bit different. Let's do a different problem. Okay, so we're going to do the 3x to the 5th power over 2x to the 4th minus 2x. Okay, so once you have that graphed, you can kind of see that we have this asymptote right here. It's a little bit slanted. Okay, I hope that makes sense. We're kind of seeing what's happening there. So, what I'm going to have you guys do is keep going. We're going to graph all 10 of them and then put them in the right spot. Officially, go ahead and pause the video, and then we'll put them where they need to go. Okay, so I don't know how this works anymore. Hopefully, I'm still recording. Timer's still going. I don't know. Okay, so here's what you should end up getting. So you should have paused, and now you're looking at this. You should end up getting something that looks like this. So this guy, well, I'll let you see this. All 5 of them. Back this up a little bit. Okay, so I know, again, I have a lot of writing on there, so just bear with me. But over here, those are the 5 that you should get. So these are all the ones that cause a horizontal asymptote. So horizontal asymptotes are caused by the different degrees that you're looking at here. So for all of these, I don't know if you noticed, but your numerator degree and your denominator degree are either the same or the numerator is smaller than your denominator. Okay, and that has to do with limits, and I don't really want to get into that right now. But you'll notice, like I said, that they're either the exact same or the numerator is smaller. So when I was in high school, my teacher taught me this little trick. So we call this the cheerleader asymptote because, I don't know if y'all seen partner stunts before where there's like a flyer that's in the air and then there's a base that's holding her up. We kind of have a little situation that happens there. So if your flyer is smaller than your base, so if your degree in your numerator is smaller than the degree in your denominator, you do have a horizontal asymptote, and it's always going to be right here at y equals 0. Okay, so we can kind of remember that is that the flyer feels like she weighs nothing because she's in the air, so she feels like she weighs 0. If the flyer is the exact same size as the base, it comes down to the number of pom-poms they have. So I know that sounds really, really goofy. Okay, but here's our example where the flyer, so your 2 here, your degree and your numerator, is the same size as the base, so the degree and the denominator. So 2 and 2 are the same. It comes down to their pom-poms, which we call the leading coefficients in this case. So your horizontal asymptote will be y is equal to, and then 5 over 1, which is 5. So like this guy right here, the degree in my numerator is smaller than the degree in my denominator. So the cheerleader feels like she weighs nothing. So your horizontal asymptote is nothing. It's 0. Here you have the same in the numerator as in the denominator. So it comes down to the number of pom-poms. So 8 divided by 4, your leading coefficients, which is 2. Okay, here for this guy, your numerator is smaller than your denominator. Okay, so the cheerleader feels like she weighs 0 pounds. So your horizontal asymptote is y equals 0. And then here they are the same, so it comes down to your leading coefficient. So 1 divided by 2. So your horizontal asymptote was 1 over 2. Okay, now you don't always have a horizontal asymptote. And the situation where you wouldn't is if your flyer is bigger than your base. So I don't know if any of y'all have seen the movie Dodgeball before, but there's a whole scene where the flyer is way bigger than her base and she squishes him. So that's kind of the same situation that happens here. The bigger flyer squishes the smaller base. So that in this case, the situation is that the horizontal asymptote would not exist. So this DNE stands for does not exist. Okay, so you have, if your degree in the numerator is bigger than your degree in the denominator, then you don't have a horizontal asymptote. Okay, so then over here for our slant asymptotes, like I said, I know I have a lot of work, so bear with me. Your slant asymptotes are the ones that, if you look, your degree in your numerator is 1 bigger than your degree in the denominator. So like 5 is 1 bigger than 4, and 4 is 1 bigger than 3, and 3 is 1 bigger than 2, and so on and so forth. Okay, so the slant asymptote is always going to be the equation of a line. You kind of just have to play with it and figure out what it's going to be. And by play with it, I mean actually divide. So we're going to take that 3x to the 5th. We're going to divide it by 2x to the 4th minus 2x. Okay, what's kind of awesome is that once you get to a place where you have a remainder, so like since this 2 is smaller than this 4, you have a remainder. You don't care about the remainder anymore. You don't care about anything else after the remainder. You just care about this part. So that's going to be your slant asymptote. Excuse me. Okay, so in this case, since we divided 3x to the 5th, you have to do long division. I'm really sorry. But you think to yourself again, 2 times something gives you 3x to the 5th. So in this case, that's 3/2 x. So you multiply by 3/2 x, and you subtract it. So your slant asymptote is y is equal to 3/2 x. Okay, in this next one, we have a slant asymptote because my degree in my numerator is 1 bigger than the degree in my denominator. So I'm going to take that numerator, and I wrote zeros out just because we don't have any other factors here, or any other terms. And I wrote in pencil too, and it's not wanting to focus. I wonder if I can. Oh, looky there. Okay. So the degree in my numerator is 1 bigger than the degree in my denominator. Okay, so you go through and you divide, and you end up with 1/2 x. So your slant asymptote is y is equal to 1/2 x. Make sure, it's really, really important that you write the equation, so y equals over here. Because if you don't, then you don't have an equation, you just have an expression, and that causes kind of an issue because you can't graph an expression. Okay, so in the next one, if we have 3x cubed plus x over 2x squared minus 2, you're going to again divide that numerator by that denominator. And again, you don't really care about your remainder. All that you care about is what you have in your, or what you have as your quotient. So in this case, we have 3/2 x. So your slant asymptote is y is equal to 3/2 x. This guy down here, same kind of thing. My numerator is 1 bigger than my denominator, so my slant asymptote is y is equal to 1/2 because you divide your numerator by your denominator. And then in the very last one, exact same thing. You divide your numerator by your denominator, and you end up with, in this case, you have a constant, which is kind of awesome. So y is equal to 5 halves x minus 1. Okay, so I hope that was beneficial. I'm going to let you guys work on that worksheet that I've attached. I really hope this video works. If you have any questions, you can email me. Hopefully I'll be kind of close to my phone, but hope y'all have a great day.